Hello everyone, welcome to the ninth tutorial of applied probability. So this is mostly based on random processes, as quick introduction. And we'll be going over a few questions and just read through the first one and then we'll solve it. Okay, so the first question says the random process z of t is defined by z of t equals 2xt minus y, where x and y are a pair of random variables with means mx and my and variances sx squared and sy squared. I'll just write this as variance of x equals sigma x squared and variance of y equals sigma y squared. I'm just used to writing it, so I'm going to define this beforehand. The correlation coefficient is rho xy, rho sub xy. Find the mean and auto covariance of z of t. So it's fairly simple. Let's find the expected value of z of t, where z of t is defined as 2xt minus y, and get this. So the sum of expectations, this sum of two random variables inside an expectation is basically the sum of their individual expectations. So we can write this as e of 2xt minus e of y. And note that, well, there's nothing random in 2, but there's also nothing random in t. That's just time or whatever index we're using. So this will just be 2t e of x minus e of y. E of x is mx and e of y is my. So we get 2t mx minus my. Right? इसको हम define कर देते हैं as mz, and it's a function of t, so we can write that as well. Next one से पूछ रहा है कि what is the auto covariance of z of t? तो वो भी निकाल लेते हैं. Cz of t1 comma t2, this is just equal to e of z of t1 z of t2 minus mz of t1 mz of t2. That's just how it's defined, auto covariance. And we know z of t1 is 2xt1 minus y. तो हम इसको expand करते हैं, t2 का भी इसी तरह से होगा. So we'll just expand. Okay, so इसके अंदर I'm just going to simplify now. This is basic algebra, so I'm not going to go over it उस तरह से. D1, D2. I don't have a lot of space. I'm just gonna start taking out the constants already. तो मैं expected value function के अंदर सिर्फ random variables को रहने दूंगा. So this would just become 4 D1, D2 e of x squared, mind you. Then we go to the next term. This is 2 times D1 This is 2 times D1 expected value of x and y. And then we have minus 2d2 expected value of x and y. And then we have plus e of y squared. Or जो, let me just highlight this. ये term है. This this term I'm gonna simplify over here. This would become mz of t1 is just 2t1 mx minus my. So 2t1 mx minus my, 2t2 mx minus my. अब वो इसको expand करेंगे तो we're gonna get we get 4t1 t2 mx squared minus 2 t1 minus 2t1 mx my minus 2t2 mx my plus my squared. Okay, so we have the terms simplified. अब ये है कि जो ये वाली term है इसमें से हम minus कर रहे हैं दूसरी term को. Let me just add some space for just 1 second. Okay, so now that I have more space, I can write this around. So we had 4 d1 d2 e of x squared minus 2d1 e of xy minus, इसको actually हम simplify भी कर सकते हैं because e of xy is common. तो इसको कर देते हैं minus 2 d1 plus d2 e of x y plus e of y squared and then we subtract the second term. तो इसके अंदर भी हम कॉमन लेंगे. This is just minus 4 t1 t2 mx squared minus ये minus plus हो जाएगा because the whole thing is ये जो पूरी चीज है इसके साथ एक माइनस लग रहा है बेसिकली. तो okay, so plus 2 okay t1 plus t2 कर देते हैं इसको वही सिमिलर उसकी सिंप्लिफिकेशन है mx my minus my squared. ठीक है. Now what we see here अगर हम पहली दो टर्म्स को देखें that's e of इसमें हमें अगर इस टर्म को और इस टर्म को देखो this is 4 t1 t2 e of x squared minus mx squared. This is variance of x. It's the definition of the variance. E of x squared minus e of x whole squared. Okay. So I'm just gonna instead of this, I'll just write sigma x squared. Okay. Similarly, अगर हम last two terms को देखें, so that is sigma y squared. That's plus sigma y squared. और अगर हम middle वाली two terms को देखें, that's e of xy minus e of x e of y, which is covariance. And since we're given unke variances sigma x squared sigma y squared और correlation rho xy है, हम उसके covariance को उनकी notation में लिख सकते हैं. So this would be minus 2 of t1 plus t2. अब इसके covariance को हम कैसे लिखेंगे? That's just going to be sigma x sigma y rho xy. So here, this is our final answer. This is equal to CZ of T1 comma T2. ठीक है. Also keep in mind अगर हम ये निकालना चाहते हैं sigma z of t squared, z of t का variance अगर हम निकालना चाहते हैं, that's just इसके t1 t2 को हम अगर सिर्फ t denote कर दें, that's just going to give us the variance of z of t. This then becomes, we're just substituting t1 and t2 with simple t. उसके auto covariance को हम variance में convert करेंगे as follows. तो वो t1 t2 की जगह t square हो जाएगा, sigma y squared minus 4 हो जाएगा ये t sigma x sigma y rho xy. ठीक है. So that's just some additional information. वरना जहाँ तक सवाल ने पूछा था, that was covered in the first above step. Okay, moving on to the next question. ये बल्कि आप पहले एक दफा देख लें अगर you want to pause here and give it a look. And then now let's move on to the next question. Okay, give it a read. Quick read. और फिर देख लेते हैं. Let's solve it together. Excuse me. Okay, so in the second question, suppose that x of t and y of t are independent random processes and let u of t equal x of t minus y of t, v of t equal x of t plus y of t. We want to find the auto covariance of u and the cross covariance of u and x, u and y, and u and v. So how do we go about doing this? उसकी basic definitions कोई हम follow करेंगे. This cross covariance of u and x. This just becomes e of u of t1 x of t2 minus ठीक है. इसको हम एक्सपांड करते हैं. u of t1 हमें पता है x of t minus y of t है, तो ये बन जाएगा x of t1 x of t2 minus y of t1 x of t2 minus, अब ये इसके अंदर भी हम जो u of t1 है इसको x of t1 minus y of t1 कर देंगे. तो I'll just go through the, like इसको जरा thoroughly कर लेता हूँ. पिछला वाला I just wrote the result. X of t1 minus y of t2, sorry, minus y of t1, and then e of x of t2. ठीक है. This we're gonna write as is, and then यहाँ पे मैं जरा ज़्यादा जगह के लिए पहले सिर्फ इसको simplify कर दूँ. So this would become e of, let me just clarify it a bit further ताकि ये ना लगे कि ऊपर वाले को ही simplify कर रहा हूँ. मैं पहली term जो है इसको नहीं मैं अभी देख रहा हूँ. I'm just looking at the second term. The e of x of t1 minus e of y of t1, and all of this times e of x of t2. Okay, तो ये फिर बन जाएगा x of t1 times x of t2 minus e of y of t1 e of x of t2. ठीक है. अच्छा, तो अब can I select these objects? वो इंडिविजुअली होता है। खैर लिख देता। अब हम देखते हैं कि ई ऑफ ओके ई ऑफ एक्स ऑफ टी वन। अभी मैं पहली वाली टर्म वापस ला रहा हूँ। Sorry if this is a bit confusing, लेकिन I just simplified the second term पहले, and now I'm just going to go over the first term and the second term. I'm going to mix it together. Minus y of t1 x of t2, all of this minus v of x of, मैं इसको ऊपर नीचे से लिख रहा हूँ ताकि आपको अगला स्टेप सही से समझ आ जाए। Minus e of y of t1 e of x t2, ठीक है। तो these two and these two, इनको अगर हम आपस में अच्छा ये जो माइनस है जब ये ओवरऑल इसमें माइनस लगेगा तो ये प्लस हो जाएगा, ठीक है। सो अगर हम पहली इसको और इसको देखें तो this is just the auto covariance of x with respect to t1 and t2. So this just becomes cx t1 comma t2 minus cyx t1 comma t2। ये माइनस इसलिए आया है क्योंकि उसके साइंस ऑपोजिट हैं। पहले वाले में माइनस है कि the expectation of y of t1 x of t2 is minus, and then e of y of t1 times e of x of t2 is plus। तो ओवरऑल इस पे माइनस आ जाएगा हम अगर इसको कॉमन ले लें। अब हमें पता है कि x and y are independent, तो we don't really need to care about this because this will just go to 0। तो हमारे पास आ गया cx of t1 comma t2, ठीक है। इसी तरह उसको कर लेंगे सी यू वाई को। उसको हम देखते हैं फिर वही डेफिनेशन के थ्रू। एक सेकेंड, इसको मैं स्पेस यहाँ क्रिएट कर लूँ। ओके, तो डेफिनेशन इसकी क्या कहती है? That just says कि हम u of t1 लें, y of t2 लें, and then subtract उनकी individual expectations। ठीक है, that is 2, yeah। This is then equal to उसको मैं सिंप्लीफाई करके लिखता हूँ। सारी वही सिंप्लीफिकेशन है जो हमने फर्स्ट स्टेप में की थी, तो you should be able to do this on your own, उसी को देख कर। That is u of, sorry, not u, u को हमने खोल दिया, x minus y आया, तो इसमें that's just y of t1 and then y of t2। इसमें से हम सब्ट्रैक्ट करेंगे, तो वही u of t1 को खोल के जो फिर यहाँ पे हमने इधर और इधर मैंने जो किया था वही करेंगे, ठीक है। तो ये इसमें से हम सब्ट्रैक्ट करेंगे जो भी उसकी सिंप्लीफाइड फॉर्म होगी, which is e of x of t1 e of y of t2 plus e of y of t1 and then e of y of t2, ठीक है। तो पहला वाला हमें cxy देगा, वही cxy of t1 and t2, which we can again say that this is equal to 0, and then हम 0 क्यों कह रहे हैं, because we know x and y are independent, तो उनका आपस में कोई नहीं होगा relation। and then दूसरे पे हमारे पास आएगा minus, so this will be equal to minus c of y, c sub y t1 comma t2, which is our final answer for this part. So the third part है वो you guys can try to do on your own. अगर कोई मसला आता है you can always email, लेकिन यही steps follow होंगे mostly. So yep, I'm going to move on to the third question. आखिरी part में बस ये कि u और v दोनों का है, तो उसमें x of t minus y of t और x of t plus y of t होगा, जरा लंबी हो जाती है उसकी simplification. अच्छा, third question is here. आप पढ़ लें एक दफा और फिर we can go through it. Okay, so this says let y1, y2, and y3 be a sequence of independently and identically distributed random variables with mean equal to 0 and variance equal to 4 of the individual yi's. Define a discrete time random process, DTRP, as follows. It's just the sum of all of the yi's, okay, where n belongs to the set of natural numbers. Find mu x of n and Rx of m and n. That's the autocorrelation of respect to x of m and n. For all n, m belong to n, capital N. So isko, how do we go about doing this? Let's first look at yeah. Let's first go about क्या है mu x, ठीक है। Mean निकालने के लिए we're just gonna take the expected value of the random process. ये बस I'm just gonna write it as the sum of yi's from right 0 to n, ठीक है। अब हमें पता है कि इंडिविजुअल yi's का जो एक्सपेक्टेशन है वो 0 है, तो उसकी सम की भी दिस इज हमें पता है कि जो एक्सपेक्टेड वैल्यू के अंदर अगर सम हो तो that's just equal to the sum of the expected values. तो ये 1 होगा, I is 1 to n, ठीक है। और हमें पता है E of y I is 0, तो this is just 0, ठीक है। अब ऑटो कोरिलेशन फाइंड करने के लिए लेट्स फर्स्ट assume कि m is less than n. Let m be less than n, then Rx m n equals by definition ये क्यों है ये, इसके आगे मैं मीन्स क्यों नहीं डाल रहा, because that's 0. So we're just left with this from the autocorrelation key definition. So E of x of m and x of n times x of n, इसको हम सिंप्लीफाई कर सकते हैं। अगर हमें पता है कि m is less than n, तो हम क्या कर सकते हैं, एक तो हमारे पास आ गया x of m, ठीक है, और x of n जो है, n अगर x m से बड़ा है तो हम इसको ऐसे लिख सकते हैं, सॉरी दिस ऐसे नहीं। तो x of m बेसिकली क्या है, पहले m y I इसका सम है, ठीक है। तो यहाँ पे फिर आएगा y m plus 1 plus y m plus 2 plus y इसको plus dot 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 ठीक है। That's just, उसको हम मतलब ऐसे लिख सकते हैं कि x of m हमें पता है less than n है, तो it's gonna be some positive integer पीछे n से, और उससे ज्यादा कुछ y i's होंगे up till n, okay। I'm sorry, my iPad was glitching. I think अभी भी कुछ चीजें गायब है इसमें से, तो let m be less than n, और उसके बाद सारा कुछ हुआ है, ठीक है। तो now we simplify this, we get x of m squared plus, अब वो हर y m plus हर y I के साथ x of m जो है मल्टीप्लाई हो गया, ठीक है। तो मैं उसको ऐसे लिख सकता हूँ, can I separate the expectations? Of course, their IID. What is this? This is this is the sum of their individual expectations. Once again, we've already established that's 0, so this will also be 0. Okay. Okay, we're just left with e of x of m whole squared. And now note that since expectation of x of m is 0, sorry, हम यहाँ ये लिख सकते हैं ना, whole squared. This is 0, तो हम ये लिख सकते हैं, there is no problem with that. तो ये फिर क्या बनता है? This is the variance of x of m and the variance of x of m is the variance of their individual y i's summed up. So this is equal to variance of y1 plus variance of y2 and so on till variance of y m. So this will equal to 4m. Okay, for 4m क्यों? Because we know that individual yi की variance is 4. We're summing it up m times, so this will just be 4m. Or for n is for n is less than m, यहाँ पे n greater than m था. So for n is less than m, or for n less than m, we will have the result of this will just be 4n. And you can see that वही चीजें होंगी सारी बस रिवर्स हो जाएगा. तो we'll know कि जब m n से छोटा होगा तो हमारे पास 4n आएगा, जब m n से छोटा होगा तो हमारे पास 4m आएगा. तो फिर the final answer is, इसको मैं रेड में लिख देता हूँ कि r x of m n equals 4 min n and n. ठीक है? So this is just the minimum of 4 times the minimum of m and n. All right. Have a look at the solution. See if you understand it, and then let's just move on to the next question. You may pause here if you want to look at it. The question 4, I'll just go through it. It says a discrete time random process xn is defined as follows. A fair coin is tossed. If the outcome is heads, xn equals 1 for all n, and xn equals -1 for all n. Otherwise, alright, wrong. And xn equals -1 for all n otherwise. मतलब अगर tails आए तो xn will equal to -1. So part A is asking for whether xn is a WSS random process. So that's wide sense stationary random process. उसके लिए क्या चाहिए होता है हमें? We need the mean to be constant. So for A, let's look at E of xn. हमें पता है कि जब head होगा तो 1 होगा, tail होगा तो -1 होगा, तो probability of head times 1 plus probability of tail times -1. Probability of head and tail is 1/2. This coin is unbiased. So this will equal to 0, which just means that the mean is constant. Second requirement क्या होती है? Second requirement is that we need the auto covariance to be a function of t1 minus t2. तो उसको भी देख लेते हैं. Let's look at the auto covariance. जैसे मैं n1 और n2 ले रहा हूँ, आप t1 t2 उसको assume कर लें. It's the same thing. This is just the definition of auto covariance. So I'm just going to write that down. हमें पता है कि just write the same thing. Yeah, one sec. My bad. This is the expectation of xn1 times the expectation of xn2. हमें पता है कि this and this is 0. So this whole thing will equal to 0. And we'll just be left with E of xn1 and xn2. So the expectation of xn1, xn2 equals the probability of head times 1 times 1. ये 1 times 1 क्यों हो रहा है? Because if it's head, both xn1 and xn2 will equal to 1. And probability of tail -1 times -1. Because when it's tail, both of them will be -1. This is 1/2 plus 1/2 equals 1. And it's a constant. We can say that this is a function of anything. So this is a function of t1 minus t2. मैं अगर इसके साथ add कर दूं 0 times t1 minus t2, that works. So therefore, ठीक है. Part B क्या पूछ रहा है? Part B पूछ रहा है if it's stationary. Stationarity के लिए we must look at the autocorrelation. पहले हम देखते हैं कि first order PMF के हिसाब से variance क्या बनती है. That is just equal to the expected value of xn squared minus the expected value of xn whole squared. 1 minus 0 हो जाएगा ये. Weight of 1. ऊपर से हमें पता है कि this will also, यहाँ देख भी सकते हैं, this will also equal 1. Third order PMF के लिए भी हम देख लेते हैं कि क्या होगा. So in the third order PMF, we will have the probability of x1 equals xn1 equals k1 comma xn2 equals k2 comma xn3 equals k3. इस सारी चीज की जो PMF है, that will just be 1/2 for k1 equals k2 equals k3 equals 1, and 1/2 for -1 and 0 otherwise, just to complete it. तो हमें पता है कि ये orders के हिसाब से change नहीं होगा, it's a constant PMF. And it's not dependent on sample difference. तो अगर हम जितने भी उसको करें, it won't depend on that. So we know कि xn is stationary. क्योंकि हम इसको nth order तक भी ले जाएं तो ये ऐसे ही रहेगा. Therefore, xn is stationary. Just to clarify, random process stationary कब होता है? जब उसकी जो distribution है, that is not affected. It's statistical properties. They do not change by time. तो हम उसकी variance को देख रहे हैं यहाँ पर. For example, it should not change with time or whatever index we have. So for whatever n1, n2, n3, and so on till the nth order, ये हमने third order तक लिया था. We know that it won't change. So we can, fairly say that xn is stationary. So that brings us to the end of the tutorial. Just focus on your first principles, focus on your basic understandings of random variables, because that's what make up the random process. Sorry, wahi cheezein that you've done before, expected values, variances. The concepts are new. They require further understanding. Lekin make sure your basics are strong, so you should do well on the quiz. Best of luck. And that will be all for today.